హాయ్ స్టూడెంట్స్, దిస్ ఇస్ శ్రీనివాస్. మీరు చూస్తున్నారు కేబీ టెలివిజన్. వెల్కమ్ టు ఈ క్లాసెస్. ఎంతగా ప్రాక్టీస్ చేసినా ఎక్స్పర్ట్ సలహాలు సూచనలు లేకుంటే మ్యాథమెటిక్స్ను వంట పట్టించుకోవడం విద్యార్థులకు కష్టమే. అందుకే మ్యాథ్స్ పరీక్ష అంటే విద్యార్థులు బెంబేలెత్తిపోతుంటారు. ఈ టెండెన్సీ ఇంటర్ సెకండ్ ఇయర్లో అయితే మరీ ఎక్కువగా కనిపిస్తుంది. ఈ అంశాన్ని దృష్టిలో ఉంచుకునే కేబీ టెలివిజన్ ప్రత్యేకంగా ఉచితంగా ఈ క్లాసెస్ నిర్వహిస్తోంది. ఈ క్లాసెస్లో కలిగే సందేహాల నివృత్తికి ఈ ట్యూషన్స్ కూడా ప్రారంభించబోతున్నామని తెలిపేందుకు సంతోషిస్తున్నాం. ముందుగా ఇవాల్టి Maths-2a క్లాసులోకి ఎంటర్ అయిపోదామా? డియర్ స్టూడెంట్స్, నిన్నటి ఎపిసోడ్లో పర్మ్యుటేషన్స్ అండ్ కాంబినేషన్స్ టాపిక్కు సంబంధించి ఇంట్రడక్షన్ మరియు సినాప్సిస్ గురించి తెలుసుకున్నాం కదా. మరి ఈరోజు ఎపిసోడ్లో ఇదే టాపిక్కు సంబంధించి పర్మ్యుటేషన్స్ ఆఫ్ ఎన్ డిస్టింక్ట్ ఆబ్జెక్ట్ వెన్ రిపిటేషన్స్ ఆర్ అలౌడ్ గురించి తెలుసుకుందాం. మరి ఆ టాపిక్ను మ్యాథ్స్ బోధనలో విశేష అనుభవం గల నాగశ్రీ గారు వివరిస్తారు.
We started permutations, combinations with some restrictions also. We counted the number of permutations which can be formed by using the given. Now another type of question. There are n distinct objects are given, or distinct objects. These are given, and now the question is, find the number of permutations formed by these n distinct objects when repetition is allowed. What is meant by repetition is allowed? Again, I have n places to fill up. Now there are n distinct objects. In how many ways can I fill up this? N ways. In how many ways can I fill up this? Again n ways, because now I have given one clause, repetition is allowed. Whichever is used, that can be used here also. So then this has also n choices. Okay, this. So the last one also has n choices. So this is n power n. So number of permutations of n distinct objects using all when repetition is allowed is n power n. Right down. Number of permutations of n distinct objects when repetition is allowed is, what is that? N power n. Okay. Now let us do one example. There are 5 digits. How many 5-digit numbers can be formed by using this? Let us see. 5-digit numbers. Again, we divided the job into 5 parts. Filling up this part, how many ways? Natural restriction is there for this. Don't simply go by formula, concept. This can be filled in. This can be filled in. This can be filled in. This can be filled in 5 ways. So total? Write down. Number of 5 power 4. Number of permutations, number of 5-digit numbers. Number of 5-digit numbers formed by using the numbers 0, 1, 2, 3, 4. When repetition is allowed. Next question. Find the number of find the number of 5-digit even numbers. Find the number of 5-digit even numbers which can be formed by using the digits 0, 1, 2, 3, 4. When repetition is allowed. When repetition is allowed. Now, what are the places of restriction? First and last. So, in how many ways can we fill up this first one? The last one? What are those 3 ways? And this can be filled in? So, 5 into 5. This is 12 into 125. Okay? Restricted places first you have to fill up and then the remaining. Here repetition is allowed. Okay? Now, the next is, till now what we are using, whatever the number of objects are there, we are using them in a, that means we are arranging them in a row. Now, objects are there, n objects, we need not use them to form, use all of them to form any permutation, only some of them. How can we do that? Let us see now. There are n distinct objects. N distinct objects are there. These are given. Now, the number of permutations of R objects taken from the above given n objects. Permutations of R objects which are taken from the above given n objects. Here n is greater than R. So more objects are there with me, only R objects are to be arranged in a row. Okay? Without repetition. First without repetition only. For this, how to analyze this? Now we have R places to fill up. We have R places to fill up and without repetition. Now tell me, in how many ways can I fill up the first place? N ways. Second one? N minus 1. Third one? Fourth one? And so on. Rth one? N minus R minus. So, N, first place N minus N place, N ways, second place N minus 1, third place N minus 2, fourth place N minus 3 and rth place N minus of R minus 1. Okay. If you observe, these are all consecutive integers, descending order, starting from N. How many consecutive integers are there here? R consecutive integers in descending order starting from N. Okay. How many are there? Only R places. So only R consecutive integers starting from N and decreasing order and R consecutive integers are there. Okay. This is denoted by NPR, number of permutations of R objects out of N objects when repetition is not allowed. So, in words I can say NPR is product of R consecutive integers starting from n in descending order. This is very important, this notation. And what is that? NPR is product of r consecutive integers starting from